Okay, so today I'd like to talk about a bit of a different development approach, which I decided to call time-driven development, just for the controversy of it. And when I say time, it's not that I mean time like making sure everything is done quick and without thinking of the consequences, but in general, using time, development time, as the most important metric when deciding on what to develop or how to approach the development concept. And to explain this, I will go through a couple of my personal experiences and how different decisions actually made the road for whatever we were developing at the time. Just a bit of a background for myself. My name is Katerina. I am co-founder and CEO of Adiva, which is a remote network of tech professionals. We're on a mission to enable work without boundaries by connecting remote engineers with companies who want to scale fast. And during my journey at Adiva and before, I've been working as a consultant with startups and Fortune 500 companies, so various different types of organizations. And I've noticed that in each of those, the development time was the single most important metric when it came to improving team productivity and efficiency in the teams and deliveries, of course. So that's what I aim to focus this presentation on. Just a bit of a background where time-driven development came from. So on one side, we have Uncle Bob and the followers who are constantly advocating for writing good code, writing clean code. So we fully test our software, or we practice TDD, or we follow Solid. And the thing that triggered me here is that we are proud of doing that. We're not proud of writing good software or creating value for our customers, but we're proud of how we've done it. And this whole mindset has created a bit of a toxic culture. I saw this tweet a while ago where Johannes here was explaining that he was just polishing some piece of meaningless code day by day, wasting time that he could have spent much more wisely. And that's the reason why I thought that, okay, we have a toxic environment that values the usage of good code design as opposed to creating value for the user or creating good development experience. And essentially, those are the tools we use for achieving this in the first place. Now, on the other side, we have a very different and drastic opinion, which is Peter Levels, who says that Remote OK has been built as a single PHP file, no libraries, no frameworks, and he makes a ton of money doing that. So we don't have any balance. There are people who are advocating for good software practices at all costs. We have people who are advocating for just do it quick, whatever it takes, and then focus on the business value. But what happens in between? So my goal here was to try to find a way to create that balance, to suggest an approach that would help people decide when to focus on doing something quickly, when to invest time into doing something the proper way so that it can scale and it can be maintained in the long run. And that's where time-driven development as a concept came. So the first personal experience is switching storage on Adiva's platform. So for context, Adiva is an online platform where people can sign up, they can set up their own profiles, enter past experience and everything. And then on the other side, companies create job opportunities that we use to match people. So we need both of these to be able to do a proper match and suggest the right talent for a company. But at the beginning, we were starting small. We were a startup. We didn't have that much resources to invest into the engineering team. So we decided, okay, we will use our ATS software or a CRM for managing our candidates. And then just create a simple interface on the front end that people can see so that we can have this nice branding of Adiva's website and everything. And this is how this looked like back in the day. So just a simple website. All of the data here was pulled from that ATS system where candidates applied. And then over here, everyone could log in and edit their details. And so in the background, what we were doing here, we had libraries, classes created for pulling data from the CRM and displaying it here, then sending it back if the user wanted to update their details. But over time, and we were aware of it, over time we needed to create a custom solution, move to MySQL, and transform everything that we were doing here. So that transformation, that switch of storage was actually very costly and time demanding. And these are the things that we needed to do that switch. So first, we needed to switch to change the code, create new classes, update the current logic to use MySQL instead of the CRM class. Then we needed to change the controller dependencies accordingly. We needed to use MySQL instead of CRM to pull the data for the view. So all of the background database connections and everything had to be adapted. We had to switch all variables to the new naming convention because we didn't have anything in place at the beginning. It was just using whatever the CRM software was, the API was returning. And so all of that needed to go away and be replaced with something new. Then we had to change the way we access data in the views and finally adjust the unit test to work accordingly. So it was very, very big project to do the switch. It was even harder than starting it from scratch. And it took around 30 days to do this switch. So with everything in place, all of the testing and back and forth with the integration. And it got me thinking, okay, what would happen if we actually had a better code and thought about this change, the maintainability, the extendability of the code? Would that change something? So I did a bit of a different structure here and thinking about the better code design that we could have to save time when migrating to a new solution. So I decided to follow Solid. The first step was not to depend on concrete implementations. So instead of using the classes for working with the database directly, we decided to create repositories, use interfaces, abstract all of the database logic in the background so that we can depend on the interfaces only. And whenever we needed to do the change, we would just change the concrete implementation and everything would work out of the box. The second thing would be to be mindful about what our program expects. So think creating adapter classes, making sure that our program uses the variables in a way that we expect to use them, regardless of what the API or what MySQL would return. So we would use different adapter classes over here, check the response from the API, then return it in a way that would be useful for our program. And doing this would mean that whenever we need to change it, change the storage in the future, we would just need to adapt the database logic and everything else would work out of the box. And this is my favorite of the solids open-close principle. So it says that we shouldn't change our existing code, but we should add new code. And this is a thing that's very important for scalability and for making sure that our code becomes robust and over time it gets tested enough so that it doesn't break the core of the system. And whenever possible, we need to create new classes when we want to extend or change something, and then the basics, the core of the system should stay intact to allow us for this stability and robustness of the system. So having these things in mind, creating a structure, a code structure that would follow these principles, it would mean that we only need to do three simple things, which is create new classes now to use with MySQL. Then create MySQL candidate repository that would implement the set interface and change the binding. Most of the modern frameworks have this out of the box, it's working directly. So you can just bind the implementation with the interface, and it would all work straight away. So this is what we did, and the estimated time for this switch was 5 days. So this is a scenario where thinking about the long-term impact of the fast solutions and compromising with the quality of the code can really, really have an impact on the time the development team spends on the long run and how they spend it. On the other side, this is another experience which we had when we wanted to integrate GitHub with our platform. So this would mean that people can add their GitHub profiles, and we would connect them and automatically look for some code samples to scan. And what we wanted to do actually was create, learning from the past experience, create a solution that would be easy to extend with GitLab, Bitbucket, whatever Git engine we'd like to use in the future. And so we abstracted all of the dependencies so that the controller doesn't care what happens under the hood. We used a combination of strategy and factory to handle different Git plans. We created interfaces. We created an adapter class that will return the proper response so that the program knows what to expect. So everything that we've learned in the past experience, we implemented it here. And at the end, we ended up spending too much time on designing code for a tool that we didn't use because it turned out that this wasn't thought through and that our team didn't find it valuable at that point. Or we were so preoccupied with what we could do that we didn't think about what we should. And this is the example of how things can go wrong when focusing too much on proper code architecture and spending time on crafting good code when you could spend that same time bringing value to the customer and working on something that actually supports the product. In this case, tech debt is very welcome, and that's in scenarios when we experiment with new tools and features that don't have clear long-term value, or when we work on MVPs that will probably need to be recoded after user feedback. So these are two scenarios where we definitely need to think about whether it makes sense to invest so much time into creating the proper code architecture at the moment, or we can start small and then over time extend as needed and refactor as needed. And this is a third scenario where it could be okay, but we need to be cautious. It's when there is new feature or bug fix that should be delivered fast. And especially something that creates more value for the customer has to be delivered fast, and then we can go back and sort it out. It can go like that, but it's very important to come back and sort that tech debt because it can accumulate and cause much bigger problems over time. You will notice that all the time I'm focusing on the customer value and how we spend our time to create the most value for the product, because essentially that's what we are hired to do, right? The thing with time-driven development is there's always a common trade-off. So spending less time now will cause us to spend more time later. So we need to be really thoughtful about this and decide how to manage our time properly. Why? We need to know the trade-offs because all of the software design practices come with trade-offs. If we decide to spend time right now on crafting a good code design, that might take our time from something else and vice versa. So knowing our trade-offs and deciding how best to work with them is essential. And it's very important here to focus on the value of the business, on the big picture, on why we're working on the features that we currently work on, because knowing that would enable us to make the proper decision. And working with our teams to pass that why is extremely important if we want them to be autonomous and do these decisions on their own. Then a mistake that everyone makes is that good coding design practices should simplify our lives, not complicate them. If we get to a point where we just do good coding practices just for the sake of doing it and not for simplifying our lives as developers, then that's a sign that we're doing something wrong. And as I said, thinking about the bigger picture will help us create more value for the business, for the product, for the customers. And I'd like to leave you with this thought as an answer. Good code is our tool. It's not our goal. So we should be very mindful of it. We should pass that thought to all of our teams, the developers we work with, and make sure that everyone can understand the trade-offs based on the big picture and make the right decisions. Thank you.